The Leopard 2 chassis entered service in 1979, yet 50 years later it remains the structural foundation of European land defense, evolving through decades of technological upheaval to counter modern threats. For decades, the standard response to advanced anti-tank guided missiles was to bolt thicker, denser steel and composite plates onto the hull. But the penetrative power of modern munitions has outpaced the physical properties of passive armor. To understand the solution, we have to deconstruct the engineering evolution of the Leopard 2A7 family, specifically the German A7V, the Hungarian A7HU, and the radical 2A7A1. Keeping this legacy platform relevant required pushing the 70-ton chassis limit to its breaking point, eventually shifting the survival metric from absorbing impacts to computational interception. The baseline Leopard 2A4 featured flat, vertical turret armor. As kinetic energy penetrators became more effective, that flat profile became a structural liability. The 2A5 variant addressed this by welding wedge-shaped applique armor onto the turret face, specifically angled to alter the impact trajectory and deflect incoming kinetic penetrators. Upgrading survivability immediately demanded an upgrade in lethality. The 2A6 variant replaced the standard L/44 gun with Rheinmetall's 120mm L/55 smoothbore. You can see the scale of these elongated barrels awaiting assembly here. That added length allows expanding propellant gases more time to push the projectile, generating higher muzzle velocities. The modern L/55A1 variant takes this further. Engineers hardened the chamber geometry and reinforced the barrel steel to safely contain massive spikes in peak internal pressure. Confining that pressure allows advanced programmable rounds and sabots, like the DM53 and DM73, to strike targets with 18 to 20 megajoules of kinetic energy. However, maximizing this lethality and adding the wedge armor required heavy structural reinforcements. This sparked a cycle of weight accumulation on the aging chassis that passive steel could not sustain. The Leopard 2A7 baseline marks the point where mechanical upgrades gave way to a digitized optronic architecture. The tank became a heavy sensor platform. To power this architecture, a 20-kilowatt auxiliary power unit, or APU, was integrated into the rear hull. This APU enables the silent watch doctrine. The crew operates high-resolution thermal sights and digital battle management systems without starting the massive main diesel engine. Running off the APU masks the tank's acoustic noise and reduces its thermal bloom. During an ambush, the vehicle can sit quietly in a tree line, scanning for targets while remaining virtually invisible to enemy thermals. That power feeds a dual-sight architecture. The gunner tracks targets through the EMES-15 sight, while the commander operates the independent PERI-RTWL digital panoramic sight on the roof. This diagram illustrates the hunter-killer optronic loop. While the gunner engages target A, the commander is already scanning for and tagging target B. Once the first shot fires, the turret automatically slews to the commander's tagged target. Splitting the search and engage functions between two independent digital sights slashes target acquisition time, ensuring the Leopard fires first in complex environments. The 2A7 designation does not refer to a single tank. It is a modular baseline customized to fit the specific combat doctrines of purchasing nations. This specification table compares the German 2A7V with the Hungarian 2A7HU. Both share a baseline but apply mass differently. Built for high-intensity warfare, German engineers reinforced the 2A7V's front hull and lower glacis with heavy passive armor plates. On the physical vehicle, this appears as visibly thickened add-on armor bolted directly over the front chassis. Hungary's doctrine dictates a different approach. Anticipating urban and hybrid combat scenarios, the Hungarian 2A7HU abandons the heavy frontal hull plates. Instead, they used that weight capacity for urban-specific modules, thickened roof armor to defend against drones and top attack munitions, and an FN Herstal remote weapon station to engage elevated infantry threats without exposing the crew. Modularity makes the 2A7 highly adaptable, but every doctrinal addition pushes the original suspension and drivetrain closer to their absolute physical breaking points. The engineering threshold for the original Leopard 2 chassis sits at roughly 70 tons. Moving nearly 140,000 pounds of steel requires massive torque. The vehicle relies on modified final drives and an upgraded rank transmission just to rotate the tracks without shearing internal gearing. It also requires the scale of the MTU MB873 engine to haul that mass across a battlefield while maintaining an effective power-to-weight ratio. This graph plots the relentless accumulation of mass. The platform started as a 55-ton A4. As lethality and protection increased, the mass steadily climbed until the A7 configurations hit a flashing red line at 70 tons. Crossing this weight limit carries severe tactical consequences: loss of cross-country mobility, rapid suspension failure, and an inability to cross standard European bridges. The chassis was maxed out. Engineers could not weld another inch of passive steel onto the hull without destroying its mobility, so they were forced to find a weightless way to protect the tank against modern threats. The Leopard 2A7A1 solves the weight crisis by integrating the Israeli Trophy Active Protection System. Rather than layering more steel, the system is physically integrated onto the turret geometry using flat Euro Trophy radar panels and a dual launcher unit. This replaces passive mass by projecting a 360-degree hard-kill perimeter. 4 continuous radar arrays scan the environment, searching for the specific velocity signatures of incoming rockets and guided missiles. When a threat is detected, the radar locks the trajectory, and the system instantly deploys an explosive countermeasure. In milliseconds, the algorithm calculates the incoming speed, establishes a precise intercept point, and detonates the countermeasure, neutralizing the threat in midair before it ever touches the hull. This radar array also provides an offensive capability known as fire source location. Because the radar maps the exact trajectory of the incoming projectile, it instantly calculates the origin point and feeds those coordinates into the battle management system. The crew can immediately slew the main gun to the enemy position and return fire. Trophy integrates protection directly into the tank's digital architecture, neutralizing threats through rapid digital processing. The 2A7A1 is not the final destination of the program, but a highly successful operational testbed for active protection integration. Proving Trophy works on the A7A1 chassis cleared the engineering path for the upcoming Leopard 2A8, which features this system as a standard factory component. By mastering the shift to computational defense, the Leopard 2 platform has defied its 1970s origins, boldly ensuring its position as the primary heavy combat platform of European ground combat for decades to come.